Hi all, today we'll be discussing LeetCode problem of the day, number of ways to paint n cross 3 grid. So here you're given a grid which has exactly 3 columns and n number of rows. So this is n and the columns will be always 3. So you have to paint each cell of the grid with exactly one of the color red, yellow or green. And you have to make sure that no two adjacent cells have the same color. That means suppose if you have a red here, then you can't have red in the top, you can't have red in the bottom, you can't have in the left or in the right. So adjacent in all 4 directions, you can't have the same color. So you're given n, which is the number of rows in the grid. You have to return number of ways you can paint the entire grid. And as the answer can be very large, you have to compute the answer modulo 10 power 9 plus 7 and return the remainder. So for example, if we have n equal to 2, so we have a 2 cross 3 grid like this. And one possible way to color it, suppose I put a red here, then green, maybe again red. And here I painted with a green. Here I need to change, I can maybe put a yellow. Then here I painted with a green. So this is one possible way to paint this 2 cross 3 grid. And at the end, you just have to count all the ways you can paint this grid. Okay, now let's look at the first example. So here n equal to 1. So you have one row and the column is always 3. So for this, the output is 12. As we can see in the diagram, these are the 12 ways we can paint this grid so that no two adjacent cells are have the same color. Now let's look at the second example. So for this, n is 5000. So I really can't draw 5000 rows now and validate this output. So for now, let's say this output is true. Now coming to the constraints, n will be the size of the grid, grid length, which is, the number of rows, and the number of rows can be from 1 to 5000. Now let's go the approach. So here we have 3 colors, which is red, yellow, and green. And suppose let's pick one row, which has 3 columns. So if I start coloring it, first let's say I paint it with red. After this, I have two choices, whether I can paint it with yellow or green. So maybe I pick yellow. Now after this, for here again, I have two choices. Either I can paint it with the red or I can paint it with the green because I can't paint it with yellow. So let's say I paint it with green. So this is a type which has all 3 colors as different. So let's say this is a different type of coloring. Now let's see another type of coloring. Suppose I first paint it with red, then maybe I paint it with white. So after this, I have two choices for the last. I can paint either green or either red because I can't paint white. So instead of green, now if I paint a red, so this is of type same because we can see the first and the last have the same color. And in the middle, it can be anything different. The middle also can't be the same because then it will violate the adjacent same color property. So this is the second type of coloring we can have. Let us say we'll have it as same. So for each row, let us split the count into 2 parts. The first part is of the type different. That means all the colors should be different, and the second type should be all the colors are same. So from the example, we can see, suppose we want to see which colors are all different. This is one example. Let me use a different color, maybe blue. Yeah. So in this case, in this coloring, all the 3 are different. So this falls under this category. Same with this and this 3, 4, 5, and 6. So all these 6 colorings fall under the different color category because all the colors are different. Now the remaining one, which is this. Here if we see, the first and last are same, so it falls under the same category. Here as well, the first and last color is same, which is yellow. Here as well, both are green. Here first and last are green. Here first and last are yellow. And similarly, here the first and last are red. So these six coloring fall under the same coloring category. So if we add them, so in the same we have total 6 colorings. In the different we have 6. So total, if we add it, we get 12, which is the answer for the first case. So here we just counted the answer as 6. So mathematically, if you want to prove the answer, let's do that as well. So for the different case, so in the first position, you have 3 ways to color it. You can either color it red, green, or yellow. Now in the second position, you can't color it with the same color as the first one. So you have only 2 choices here. So suppose if you paint red here you have only choices as yellow or green. You can't put red. So that's why here you have 2 choices. Now in the third position, you have only one choice, which is the remaining color. So one choice here. So in total, 3 into 2 into 1, you have 6 choices. So this is for the different case. Now for the same case, let's see how many we have. Yeah. So the same is of the type ABA, where the first and last have the same color and the middle has a different color. Now let's say for the first, I have 3 choices. So either I can pick a red, I can pick a yellow, or I can pick a green. So since whatever color I pick here, in the last also the same color gets picked. So for the last, I don't have any choice. I have to repeat the same color as what I've picked in the first color. Now in between, I have 2 choices because the first and last are the same color. So the remaining 2 colors I can place here. So here I have 2 choices. So here as well, we can see total we have 6 choices. So for the different, we have 6. For the same, we have 6. So in total, 12. So the same property, we'll try to extend it to form the answer if we have multiple rows. So let's see how we can do that. So suppose we have many rows here. And suppose we have filled our answer until this row. Now we want to fill the answer in this row. We want to color this row. So to color this particular row, we only need to check if the colors of this row is clashing with the previous row, which is the row on the top of this. So to color this row, we don't care what the color is in the all the above rows. We only care what the color is in the row which is just on top of the current row. So now let's say that in the previous row, like we discussed, we have two coloring options. One is the same type, and one is a different type. So in the previous row, I have same and I have different. So this is for the previous row. Now for the current row, in the current row as well, we can do the coloring in 2 types. First is the same category, and next is the different. So same in the sense, it will be of type ABA, where the first and last coloring will be same, and different will be of the type ABC, where all the colors will be different. So now let's see from the previous row how we can form the current row. So let me just remove this. Okay, so here we have 2 rows. The only 2 rows we care, where this is the current row which we are trying to fill, and this is the previous row. Now, in the previous row, suppose let's say we have the coloring as the same. So that means the coloring is of type ABA. Now, if the previous row has the coloring ABA, now we want to see in how many ways we can fill the current row. So in the current row as well, we have two types. We can color it in the same type, or we can color it as a different type. So for now, let's say we want to color it same type as well. So this is what we are trying to see. The previous row is of the same type, and the current row is also we want to color it of the same type. So let's see how many ways we can do that. So the total colors we have is 3, which is ABC, and previous row is filled with ABA, let's say. Now in the middle, we have two choices. Since it is filled with B, you can either color it with A or you can color it with a C. You can color it with B because then it will clash with the top row. So after doing this, you have to fill the left and right. And since this is the same type, the left and right should be same. So in this case, you can either put a B or you can put a C. So if you put a B here, here also you have to fill with a B. And if you put a C here, here also you have to fill with a C. So here you have total 2 ways. Now let's see if the middle value is C, how many ways you have. So here you can't fill with C because then it will clash with this. And you can't fill with A as well. If you fill with A, it will clash with the top one. So the only color you can fill here is the color B. And the same thing repeats here. So in this case, you have total 1 way. So overall, you have three choices. That means if the previous row is of the type same and the current row also have to be of the type same, I have total 3 ways I can color it. So let's let's see it with one example. Let us say that the previous value, the previous row is R. Okay, let's write it clearly. R, Y, and green. So let's see what all 3 ways we have. Okay, sorry, it should be the same, right? So R, Y, R. Let's say the previous row is R, Y, R, which is of the same type. Now we look at all the 3 ways we can fill the next row, which is also of the same type. So the first option we can fill is green, green and red. Then maybe we can put a green here. Then yellow, yellow. Then one more red, yellow, yellow. So these are the only 3 coloring we can do of the same type if the previous row is also of the same type. So the total number of ways is 3. So now let's look at the other cases. Let me remove this. Yeah. So now the other cases, the current row should be different, which is I want to find this. So that means the previous row is of type ABA and the current row should be of type ABC. And let's see how many ways we can fill for that. So again, first I'll start with the middle value. So in the middle value, I have 2 choices. Either I can fill with A or I can fill with a C. Now I have to fill the left and right for each of these cases. Okay. So now first let's look at the case for C. So since C is occupied here, we have to fill A and B in either left or right. So if we see that the left and right we have A, so there's no way I can put A here or I can put an A here. So this case is not valid. So let's strike it off. Now let's look at this case where A is in the center. Now the remaining 2 elements, 2 colors I can fill here is B and C. So I can put a B here and I can put a C here, or in the reverse order. I can put a C here, then I can put a B here. So in this case, I have total two ways. So here I'll just fill the value as 2. Now let's look take an example to see how what two values we can form. So the previous row has the same coloring. Let's say the coloring is red, yellow, and red. So now for the new row, since I want it to be different, it should be of the type ABC. So let's see what the coloring type says. So one coloring I can put is red here, yellow, blue. Not blue, green. And the other coloring I can do is red, green, yellow. So these are the only two coloring options I can do. So here we can see that the new row is of the type different because all three colors are different. And the previous row is of type same. So that's why in the previous row, same. And in the new row, we have different. So total, we have two coloring options. So this is the number of ways we have found for the same type of the previous row. So now let's quickly do it similarly for the different type as well. So now let's say the previous row is of type ABC, which is the different type. So now let's see how we can color the current row. So the previous row is of type different, and the current row, let's say I want it to be same, which is of type ABA. So again, first I'll start filling the middle value. I have two choices here. I can either put an A, I can either put a C. Now, since I am filling the current value to be of type same, this and this should be the same color. So first for this, let's see what color I can fill here. So if I put a C, the C is clashing with this. So C is not an option. The only color I can put it is B. So if I put a B here and a B here, this is a valid coloring because it is not clashing with anything. So for this, we have total one choice. Now let's look for C. So for C, for the other values, I have two choices, either A or B. If I put A is clashing here. So A is not a choice. If I try with the other color, which is B, so B is not clashing with anything. So here also I have only one choice. So total, I have two choices. That means if the previous row is different, if is of the type different, and if I want the current row to be of the type same, I will have only two choices of coloring I can do. And finally, let's quickly look at the other type as well, which is different. That means the previous row is also of type different. The current row should be also of type different. So again, I'll start with the middle. I can fill with A, I can fill with C. Now I need to fill the left and right. So in the first case, I have two choices. I have two colors I have to fill, which is B and C. So if I put B and C like this, so C clashes here. So I need to put in the opposite way. I need to put C here and A here. Sorry, B here. So we have only one way. And for this as well, I have to put A and B. So I can't put A here because it will clash. So the only way I can put A is here and the other color B here. So here as well, we have one way. So total two ways we can fill. So here in this table, I'll fill 2. So from this table, what we can see is, let me quickly summarize this table. If in my previous row, it is of type same, then the current, and in the current row, I want the coloring type should also be the same, then we have 3 choices. And in the current row, if I want the coloring choice is different, then 2 choices. Similarly, if the previous row is different, then in my current row, if I want it to be same, I'll have 2 choices. And in my current row, if I also want to have it different, I have 2 choices. So now, if we want to fill our current row using the previous row, we can do it like this. So in the current row, the same will be new same will be 3 into same plus 2 into different. So this is just adding up this column. So 3 into same plus 2 into different. Now for the current row, if I want to have different, then new different will be summation of this row, which is 2 into same plus 2 into different, which is this column, 2 into same plus 2 into different. So for the first row, we can calculate the same and different as 6 and 6. So for the subsequent rows, if you want to calculate the new same and the new different of the particular row, from the previous row, this is how you calculate it. Now let's quickly code the approach. So for row number 0, we have already calculated what the same count is, what the different count is. So both are 6. So first let me take them. Same will be 6 and different will also be 6. So for row index 0, we have calculated it. So we want to start calculating from I equal to 1, I less than n. So for each subsequent row, we will calculate the new same with this formula and the new different with this formula. And at the end, we'll just return same plus different. And that will be our answer. And also we need to take a mod with 10 power 9 plus 7 every time we do it. We do the addition or the multiplication. Let me quickly take the mod value. E plus 7. So this is 10 power 9 plus 7. And since this value is in double, I need to first typecast it to int. Okay. So first in the loop, I equal to 1 is the the current row. And in the current row, if you want to calculate the new same, we need to use the same and different of the previous row. So that's why we take a new variable. Let's say new same equal to the same formula, 3 into same plus 2 into different. And at the end, take a mod so that to prevent overflow. Similarly, new different will be 2 into same plus 2 into different. And at the end, take a mod. So once you calculated the new same and the new difference, just assign it back to the same. Same equal to new same and equal to new different. So that in the next iteration, the same will have the current new same which you have calculated. Also at the end, take a mod. And since the return type is int and same and different are currently in long, we need to typecast it back to int before returning them. Okay. Okay, let me submit now. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, it's pretty straightforward. We are just iterating from 1 to n. So it will be order of n. And coming to the space complexity, we have not declared any arrays, just few variables. So it will be constant, which is order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.